If we look, group 1, this little 1 right here tells me there's only one electron in the outside ring of these atoms. That's why hydrogen is here. It only has one electron in that first energy ring. As we go across, this second column only has 2. We ignore this rule for groups 3 through 12, okay? But then we pick up on the rule again in group 13. Group 13 has 3 electrons in the outer ring. 14 has 4 electrons in the outer ring. Group 15 has 5 electrons in the outer ring. Group 16 has 6. Group 17 has 7. Group 18 has 8. What we find is as we go from left to right, the atoms become more and more stable because their outer energy ring is becoming full. Now, if you remember, I always told you, remember 2 and 8. One reason I really want you to know that rule of 8 is when an atom has 8 electrons in its outer ring, it becomes full, okay? You'll learn a little bit more about some of those energy levels, p orbitals and s orbitals in high school. But for right now, I want you to understand all these atoms in group 18, they will not accept other atoms to bind with, and they will not give away their electrons or take other electrons. They are 100% happy. So the way I always tell my students is all these atoms would like to have what group 18 atoms have, and that's a full outer ring. Okay? So this will make more sense as we start looking at ions. Okay? So here's what happens with sodium. We said sodium has 11 protons, so we can go ahead and do that. So let's go 3, let's erase this. So 3, 4, 5, 6, 7, 8, 9, may run out of blacks here, 10, 11. So it has 11 protons in the center of the atom, okay? But it also has this one electron in its outer ring, okay? It would like to have 8, okay? So in reality, it would like to have all 8 electrons to fill its outer orbital, okay? So if we had 1, 2, 3, 4, 5, 6, 7, 8. Sodium would be really, really happy. But there's a problem. Sodium only has 7. I'm sorry, it only has 1 in its outer ring. And so it wants to lose, it does not have the 7 it would like to have. Well, it's much easier to give away this electron than to gain new ones. Now, if it gives away this electron, the energy ring right below it would have 8 electrons. So it would be full, okay? And so what it's trying to do is bind up with an atom that would like to take away its 1 electron. Okay, so what happens is, in reality, remember we have to have as many, so let's go ahead and kind of view this. We're going to ignore the neutrons because the neutrons just add to the weight. So in the first energy ring we have 2. Okay, in the second energy ring we have 8. Now I'm going to kind of pair them up so you can kind of see what's going on here. So we're going to pretend like that's the inner ring right there, and this is the second ring. So here we have this second ring. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, we knew that we needed 11 electrons to balance the protons. So here's the third ring. It's got this 1 electron sitting out there that needs 7 more to fill the outer ring. Okay? Well, it doesn't have that ability. So if it's able to lose this 1 electron, then it's like this other ring becomes the outside ring. It becomes very, very happy. But there's a problem here. Let's count up the protons again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 protons, which are positive. But let's count the negative things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, if I took away this electron, there's only 10. So if I subtract those numbers, there's a remaining proton that's extra. So that means this atom has now become charged. It's become an ion. A charged ion is called a cation. If it's positive, it's called a cation. Okay? Kind of makes me think that it's very ferocious. It's like a mean cat. It wants to get out there and find somebody to take that electron from it. Okay? But as it is in the periodic table, it's got a balance of electrons, right? Because we took that one away. So it really has this one sitting out there. But it wants to have a full outer ring of electrons. Well, so what happens now is it finds this atom chlorine. Okay? Chlorine is actually a toxic gas that could kill us. I mean, it's really, really dangerous if we were to breathe it in. If we notice, chlorine is way over here in group 17. Well, remember we said group 17 atoms had 7 electrons in its outer ring. And so if we look at it, see it also has 17 protons. So I don't know that I have enough colors. We're going to use orange this time to represent the protons in chlorine, okay? So let me grab some of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so we got 17 protons in the nucleus. We're ignoring the neutrons, okay? If I have 17 protons, that also means I must have 17 electrons. So I'm going to use green for the electrons for chlorine, okay? So let me go ahead and get those together. So in the first ring we're going to have 2. I'm going to put them kind of close, okay? And then we're going to go 2, this is the second ring, 2, 4, 6, 8. So that gives me 10. Okay, I need 7 more. So 1, 2, 3, 4, 5, 6, 7. So on the next ring we got 2. Now these will be further away, but I'm trying to keep them in so the camera can see them. Here and here. If you notice, everything's paired up. There's 2 there, 2 there, 2 there, but 1 here in the outer ring. It would love to get 1 more. Well, what happened was that sodium wants to get rid of that 1. If it can give it away and give it over here to chlorine, then it becomes full now. Okay? But what happens to the protons and the electrons now? Well, if you notice inside we had 17 protons, which were positive. Now we have 17 electrons plus that 1, so we have 18 electrons. So 18 minus 7 equals 1. But now the leftover 1 is an electron, so it's minus. So now this atom has become charged negatively. Now this is called an anion. So a negative charged atom is called an anion. Well, if you remember, opposites attract. So positive things like to be attracted to negative things. Okay? So if we look at this, we're only going to look at the outside electrons. Okay? So let's pretend like we have sodium. And I'm just going to put its protons in here for a second. So here's sodium. And we're just going to look at the outside electrons. Okay? The valence electrons. So it just has that 1 electron over here that it wants to get rid of. But if I look over here at chlorine, remember it had 17. See, sodium had 11. Sodium had 17. Okay? And it had 1, 2, 3, 4, 5, 6, 7 in its outer ring. Okay? Now if sodium can give away its electron, then now it has a full set of 8 over here with chlorine. This guy loves that. And he loves the fact he got rid of that extra remaining electron. So what happens now is this one becomes negatively charged, so it has a -1 charge, and this one has a +1 charge because it has an extra proton than it does electrons. Okay? This one has 1 extra electron over what it has protons. So these guys become attracted together. So they stick. They stay real close together. And now they have formed a compound. It's kind of like a compound word, dog house, right? Forms a compound. So what this compound is called is an ionic compound. Now this ionic compound is a very common substance. This is table salt. What I always find interesting about table salt is sodium, this one over here, this guy is very reactive. If you get it near water or moisture in the air, it becomes very volatile, very dangerous, starts catching fire. This one over here, chlorine, is a dangerous toxic gas that can kill us. And so what's kind of interesting about these two guys, this one is a metal, this is a non-metal. They come together, they form salt, which we eat on our food. So when they're together, they're very unhazardous, other than maybe raising blood pressure. If you have problems with high blood pressure, it could be too much salt intake. But other than that, it's really a good, source of spice on your food. It gives a good flavor, but it's very non-volatile. When they get together, by giving away this one electron and him taking that electron away, they become very stable and they become ionized. They like each other, so they stay hovered close together because this one's positive now and this one's negative. Okay, I hope that helps you out with ions and isotopes. I hope you enjoy the lesson. Hope this helps you to understand it better. Good luck on the upcoming exams, and continue to watch this video for understanding. If you still have trouble, just come by and see me in tutoring. Shoot me an email. I'll be happy to visit with you about your misunderstandings. Okay? Thank you.